Okay, so today we are going to be talking about the first lecture, which is Unit 11, Notes 1. It's about force diagrams. And in order to talk about force diagrams, we have to define a couple of things, and then we'll walk through how to create an actual force diagram. So, first of all, we need to define force. And force is defined as a push or a pull on an object by another object. So what this picture right here is it's representing the fact that we have a balloon that's attached to a string, and it's moving, and what makes it move is the air coming out of the balloon on the other side. And so that's the kind of things that we're going to be dealing with and talking about over the course of the next couple of weeks. Now, gravitational force is the pulling force on an object by the Earth. So in this case, the object is the Earth that is pulling on anything, a human, car, toy, computer, that's pulling that object down towards the Earth. Another force is called the support force. And that's a support force on an object by a stable object that it happens to be in contact with. For example, it would be the ground, a table, etc. So what I mean by etc. is that anything that's in contact, constant contact with an object could be considered the normal force. We'll say that this is the catch-all force. If the forces that we're working with that you are responsible for understanding don't quite apply. Okay, so moving on, we have the tension force, and the tension force is a pulling force on an object by a string or a rope. Okay, so for example, I've got an open sign here, and the open sign has what appears to be a rope attached to it, and so the open sign is hanging in the air, and the tension force, which is the rope, is applying that force to the open sign, keeping it up in the air. Okay, then we have a spring force, which is a pushing force on an object by a spring that moves or attempts to move an object. So here I have a car that's next to a spring. The spring is compressed, the spring relaxes, it pushes the car, and that's what drives the object, which in this case is the car. We also have the applied force, which is kind of one that we're not going to use very often, but it's the force on an object that attempts to move or moves an object. And then the one that we're going to use most or almost all the time is the friction force, which is the force on an object touching it, which opposes or works against the movement of the object. Okay, so the five forces: gravitational force, normal force, tension force, spring force, and friction force. Those are the ones that we're going to use a lot. There are a lot of other different types of forces out there. We're only going to focus on like those five. Okay, so here I have another diagram down here. I've got a human standing on top of a skateboard. There appears to be a rope that one human is hanging onto on the skateboard and another human is holding. And as a result of that, the human on the skateboard is being pulled towards the human that is standing there. Okay, now a couple of things. I'm going to tell you that the human and the skateboard are the system, which is really important, and I'm going to show you how to draw a force diagram for the human and the skateboard. Now, in this case, we always start a force diagram by just simply putting a dot. That dot represents the system, so we don't have to redraw the human and the skateboard. We don't have to redraw the book on the table. We don't have to redraw this stuff. We just use a dot. Now, the next thing I'm going to do is I'm going to say, well, what are the forces that are acting on this particular object? And one of the things that I see is that a force that is definitely acting upon the object is the force of gravity, because it's pulling the object toward the Earth. So I'm going to draw an arrow down, and I'm going to call it the FG. Okay, so that's my FG force. Now, if the skateboard is on the ground is supporting the skateboard and the human from like falling into the earth. So we call that the normal force, Fn. Okay, and note I tried to make these arrows about the same length, indicating that they kind of sort of cancel each other out. They're both present, they're both really important, but they cancel each other out. So if the force of gravity was stronger than the normal force, then that human would be sucked inside the earth, and we don't want that. That sounds terrible. Now, the other forces that are present here are, there's that rope that is pulling the skateboarder, so we would call that the force of tension. And we also have the human is got the skateboard on the ground, and we can't ignore it because it always exists. We have the force of friction. So we have the force of friction here, okay? Now, some things that we need to kind of talk about and that makes this really important is the idea that just identifying the forces is good, but it's not quite everything that we need to do. So down below I've written writing forces, and I have a template. And the template says f of x, or fx parentheses on, comma, by, where x is the force present in question, or the force in question, the thing that we're working with, on the object. Whereas on is the object that the force is acting on. So in this case, it might be the human and the skateboard. And the by would be the object that is producing the force. So we'll kind of go through what this looks like. So in the case of force of gravity, the force of gravity, oops, we don't want that. The force of gravity is acting on the human and the skateboard. Okay, but it's acting. But the thing that's acting on the human and the skateboard is the force of gravity, and that force of gravity is being produced by the Earth. Okay, and so we also have the normal force, right? And the normal force also is working on the human and the skateboard. And the ground this time, because that's what the skateboard is resting on, is what's acting on the human and the skateboard here. So that's the ground. Oops. Okay. And then we have the tension force, which is the rope that the skateboarder is being pulled by, right? And so that would be the human, the skateboard. Okay, and the thing that is putting the force of tension on the human is the rope. And then lastly, we have the force of friction, which is being applied to the human and the skateboard, because that's what my system was. And that's being applied by the ground. So you need all of these pieces of information to help you to relay or at least explain what's going on in your system. So one more thing to make note of is that the on for all of your forces should always be the same, because that's what your system is, and the on should always be your system. Okay, so your worksheet that you're going to work on, when they're all said and done, have some arrows, and they should have the forces identified, and they should have the thing that is the force is being applied to and what's creating the force. All of that information needs to be present. Good luck with your homework, and we will talk about this tomorrow. Is this particular worksheet here, and it's got a few different scenarios. There's some things I want to tell you about the scenarios. One of the things I want to tell you about the scenarios is that the book is your system, and the book is not moving. I would like to tell you that the light bulb is your system. So this is your system, and the light bulb is your system, and the light bulb is not moving. The system here is the lady inside the car, and the lady inside the car as part of the system is not moving. The system here are the humans or the people in the catapult situation, and those ropes or those springs are holding them in place. They're also not moving. The system here is the cat, okay? The chunky cat is standing on the ramp and it's not moving. The system here is the pizza dough in the air, not moving. Now we have the system of the car, which was moving at the beginning, and it slows to a stop at the end. And then lastly, the system here is the punching bag. That's the system, and Mr. Sussex is acting upon the system. Or, yeah, is acting upon the system. So go ahead and draw force diagrams for each of these. Your force diagrams